All right, so find the voltage in the center of a square 45 centimeters on a side whose corners are occupied by 12. This is like, textbook type problem, right? So you got a charge here and a charge here and a charge here and a charge here. And all of those are 12 times 10 to the minus 6th coulombs, right? Okay, so what it's going to be is it's going to be 4 times the potential due to any one of those, right? So now the question is, what is that? What is that distance there, right? Okay, if this is 0.45, how far is it from a corner to the side there? If this whole thing here is 0.45, right? Well, I think there's something elegant, like I can divide by the square root of 2 or something like that. I'm not very elegant, though. 0.45 divided by 2 is 0.225, right? So this thing is 0.225 over 0.225 up. So that distance r is equal to the square root of 0.225 squared plus 0.225 squared, right? Okay, so the square root of 2 times this number squared is 0.3181 meters to the center, right? There's a 9 after that too. So now the voltage due to one of these charges is going to be equal to 8.99 E9 times 12 E minus 6 over 0.31819. I'm going to just use that value there, right? So 8.99 E9 times 12 E minus 6 divided by that number that I just got. Wow, that's a lot. Okay, that is 339.034 volts. So that's due to 1, right? Of the corner charges. Corner charges. Of course, there's 4 of them, right? So the total voltage would be 4 of those, just multiplied by 4, right? So 339.034 times 4, because there's 4 of them, right? There's some symmetry here, is 1356136.526, like all the digits it can give me. Okay, so that is, 1.36 times 10 to the 6th, 1.36 million volts. Look out. Yay. All right. Happy hunting.